This is a Mastech, I believe. Well, it's a sinometer. But the same thing's marketed by Mastech. MS6100. Like I said, this is a sinometer. I've owned this for a number of years. I just never got around to liking it. It always seemed unstable. I don't know why. Actually, I've had much better luck with something like this. This is a one-board, 8-digit frequency counter from China. Here's a 6-digit version of the same thing. This is the way they're sold. I put it inside this half pipe years ago, and it used to lay on the bench all the time. And at 10 megahertz, it always appeared to be 16 hertz off. But it was repeatable. Now you can get a plastic enclosure. I think I did a video maybe on making the pipe enclosure. You can get a plastic enclosure from AliExpress for the 8-digit only. I haven't found it for the 6-digit version. And it did not come with a SMA connector. That was my addition. But with this, it's auto ranging. You can select time base and high or low or auto. But since I've gotten a 10 megahertz shop distribution system that distributes what I believe to be accurate 10 megahertz from the GPS stabilized clock, I was wondering if I could convert this 10 megahertz output to an input and eliminate the internal time base and use my externally derived 10 megahertz time base. I can't find any information on this schematic wise, so I think I'll just tear it apart and see what it looks like. It appears we can just wrestle this rear cover off. It's not happy about it, but it seems to want to come off. There's a little bit of a hook there. So I guess the front will come off the same way. Alright, with the rubbers off, it looks like we just take out these 4 screws. Alright, so it looks like we have an AC power transformer. Power to here, full wave rectifier, 3-terminal regulator, and I guess that's the power supply. I would guess this is the the input for each channel. Let's see. Looks like input A goes to 100 megahertz, and input B goes to 1.3 gigahertz. Input B must be a pre-scaler, maybe, I don't know. And this is the oscillator. couple of holes here in the oscillator. Let me see if I can determine what this chip is. I've removed the shield, and you see there's 2 holes in the shield, one of which is marked 10 megahertz, and that's centered over this variable capacitor, VC2. VC1, by the way, is over here. First thing I'm going to do, after I make a schematic of this, I'm going to remove this chip and replace it with a socket. One of the standard ways of developing an oscillator is to take this crystal, put 2 capacitors on either side of the crystal, and connect them to the IC. Now these 2 capacitors are very interesting. I don't know how close I can get to them. You see, they've been cut almost with a pair of diagonals. They've been cut in half. You can see the exposed dielectric and metal plates. I don't know if they were tweaked by cutting off the tops, but I've never seen that before in a piece of commercial equipment. Also notice there's a component here called J4, which is not there. They've eliminated the jack and soldered the coax directly to the board. I have no interest in saving this chip, so rather than wrestle the chip out intact, I've just cut off all the leads on the chip. There's 14 of them. And although I don't have much to say about flush cut pliers or flush cut cutters, here's an application for flush cut right up against the body of the IC. Now I can just take them out one at a time. I've replaced this 7404 with a socket and a socketed 7404. And I've also done a complete schematic. There's 2 potential outputs from this 10 megahertz oscillator. One of them is here. And you'll see on the oscilloscope it's 9.993. And it's more or less a TTL square wave. The other output is N. You see it looks identical. Now this is a little longer and this is a little shorter. It's not quite a symmetrical square wave. I have a 10 megahertz input from my shop standard. It's 10, 3 zeros, and 359 cycles high, assuming that my shop standard is 10 megahertz. Let me show you something very, very disconcerting. I'll take out the 10 megahertz oscillator chip. Turn the unit back on. And of course, there's no output. The oscilloscope shows nothing, which is what I would expect. But look at the front panel display. Let me change the gate time a little bit here. Without the reference oscillator, it still reads 10 000359. Now, how do you explain that? When I did the schematic, it appeared to be a nice working oscillator inside this square. But I could find no connection between this square and anything out here. I took the board out, shined a light through it. It's transparent. There's no hidden traces. There's no traces on the bottom. Appears to be a two-layer board. There's no hidden traces. Does not appear to be connected to any of this. And of course, disabling it sort of verifies that. So at this point, I'm at a loss what to do. I have no schematic of the rest of this. So if anybody has any ideas, let me know. I spent 2 solid days looking, telling me that this was an impossible thing. Then I pulled that chip out and it changed nothing. So at this point, I don't know what to do. Thank you.